Hello, I'm Sumin. I'm NTU student from Business Analytics Group B. I will present my solution. This is the yellow highlighted code of bank code. CSV contains 10 banks with their merchant, this registered merchants with their bank account. Redemption CSV is hourly transaction files by matching hourly transaction data. And I expanded our test data into 40 plus rows. Let's look at the Visual Studio. I decompose the main problems into 5 sub-problems. Data loading, load these rows CSVs and convert to in-memory structures. Merchant lookup, find merchant details by ID. Bank mapping, map bank code to SWIFT code. Fourth, transaction grouping, sum amounts by transaction. Fifth, file generation, create bank-specific CSV outputs. Each sub-problem was solved with 2 different algorithms for complexity comparison. This is the case. So for time complexity, let's look at the time complexity analysis. For merchant lookup, algorithm 1 is type dictionary lookup. This is O1 average case. Algorithm 2 is linear search, testing one by one with 40 plus test rows. We observe dictionary. Dictionary is 30 times faster, selected for production. So this pattern repeated for bank mapping and grouping, always favoring hash-based, has category-based lookups over one by one scanning. I'd like to show the code demo. When you run the Python complete, you can see that it is loading with data, processing transaction, generating bank files, and all the files are generated here. So this code loaded 40 tests, matching each to the correct merchant and banks, and also group amount by transaction, generated 3 flipped code named CSV files with proper reimbursement details. So I'd like to show you of query Python file for test. This audit command line allows merchants to verify their transactions. The system generates a CSV report showing within the expected reimbursement amounts. Let's look at the demo. By this system generates a CSV report showing within an expected reimbursement amount. Audit report CSV has been created like this. This is the end of the demo. So I'd like to also share the key learning lesson with peers. So first, divide and conquer works. Breaking a large problem into smaller, testable functions make debugging much easier. Second, algorithm selection matters. I just theory, but real performance differences. And third, AI is a tool or not a shortcut. I taught me that just blindly copying code, not at all. Fourth, transparency matters. Documenting exactly when and how I used AI in the learning provenance journal when also writing made me more responsible and accountable for my own understanding as well. Also, this assignment challenged me to think like a backend engineer. How do I process real world differently? How do I verify correctness? I'm also grateful for this opportunity to apply class concepts, divide conform complexity analysis to a realistic business problem. All testing is also documented from completion section, external health complexity is transparently reported. Thank you for your time.